This is Result. You might have seen Result in such blockbusters as Unwrap, Expect, and the recent psychological thriller, Must Use. Welcome everybody to an introduction to the result type in Rust. Not a serious spy movie, but actually a really fascinating topic on API design with the Rust programming language. Rust provides this really curious but very, very useful way of handling errors, which is an enum. An enum that has two type parameters, T and E, and it's extremely confusing because if you've never used type parameters before, suddenly you have two to deal with. There are lots of excellent resources for using results in Rust, and my recommended resources are provided as links in the description below. This video, however, is going to focus more on how results work and how traits and types all link together to balance the needs of API and library designers with the needs of end users. The real significant thing about the result type is that it is just an enum, and it is an enum that you could define yourself. The significance comes from an attribute that is provided up the top. So let's just confirm to ourselves, although there's lots of noise around stability and so forth, we have fundamentally two type parameters, T and E, each relating to a specific variant of an enum with an attribute must use. That must use attribute is kind of what provides the power of Rust. It informs the compiler about the fact that it needs to nag you whenever you encounter a result. The must use attribute will coerce the caller to dealing with both sides. You can't just decide, today I'm not going to worry about the possibility of errors. But where are type constraints? And to find them, I'm going to go back into the documentation and take a look at a friend that you might have met before, the unwrap method. Unwrap adds a constraint, debug, and its cousin, expect, that you have seen as well, hopefully, which allows you to provide your own error message, has a similar constraint. So you can see here with the combination of must use that sort of requires that you actually consider all variants, and the fact that some of these usage methods compel you to have the debug implementation, you can see now where the type system is getting involved. From an API design point of view, this provides a hint about idiomatic Rust, and that is that your type constraints should really be as late as possible to enable as much flexibility as you can. It might be the case that you could define a results type yourself with your own T and your own E that you never intend to propagate all the way up to the user. Instead, you want to enable someone or require that someone defines some handler in their code when they call upon you. Now, but there is still a bit of a gap, because we need to see, we think of the variant as handling errors, but we still haven't got to the error trait. So let's take a look at the standard result documentation. You can see here that the word error appears a lot of times. The E type represents an error and contains an error value, but we know from that the type system doesn't really care what you put in the E. You could do whatever you want. So let's go look at what an error actually is. It's confusing because there are multiple definitions. What we are interested in right now is the trait. The trait has a similar constraint to expect and unwrap. We require the debug implementation, but it also requires display. You can see also that there are methods like description, cause, and source, which is relates to the source code, the location in the source code where the error was originates. That all of this has something to do with kind of informing an end user. Errors, as far as the type system are concerned, are really related to providing humans with output. The result type is primarily there for the type system and for you as a programmer to handle errors. And we can see that actually in one part of the documentation. Result relates to propagating and reacting in the context of a program, whereas the error trait is solely focused about reporting the error itself. And that's kind of interesting because even the error trait's own documentation says that it's actually there designed to be used as the type E in the result TE. Even though if we go into result, you can see that there's actually there's no type constraint there. So there is one last piece of the puzzle, and that is with all of the specializations. So the specialization that you've probably seen the most is standard IO result. What is happening with these? Well, the first thing to note is that every module is redefining result to simplify the use of that type in the context of in the module itself. So it's the specialization is because the module also provides its own custom error type. So you shrink down the number of type parameters. Now, one thing to note is that there is a further problem relating to overuse of the name, and that is that modules have their own error structs that are not the same thing as the error trait. I apologize if you're learning Rust, it is confusing, and that is something that you will breathe through and get used to. But the individual modules in the standard library are defining a trait. Sorry, they are defining a type, in this case of IO error, a struct, that happen to implement debug and display. The reason why that is significant is because all types that implement display will also then have an automatic implementation of the error trait. So you can see that the relationship between the error structs or the error types and the error trait is itself indirect via the display trait that all of the modules in the standard library happen to implement. Now, if you are more confused after watching this video, I do apologize. I would like to just reassure you that it makes sense after some time. But for now, I want you to remember that the result type itself, that is defined in standard result looks confusing. It is there to be able to provide the most flexibility as possible to people that are writing libraries. But that comes at some cost as a learner or someone that's using the result. And that is, you need to understand the dynamics of individual types or individual structs and the traits that are all related to the machinery of error handling. The result struct has two variants, OK and On the OK side, you can put in whatever you want. And on the error side, you can put in whatever you want as well. But if you need to be able to report that error back, which happens in well over 99% of cases, your E inside must also implement debug and probably also implement display. I hope that's been useful, And feel free to ask any questions that you would like in the comments. I'm expecting several. Well done. Hopefully this has been informative, and I will wish you well for the rest of the day. Goodbye.